So today in your Edmodo, you are going to go to the post that says 831 Scientific Notation. We have the link for the reading, we have our practice questions, and we have my email that you send your answers to. So, what is scientific notation? Well, in science, sometimes we have to deal with very big numbers or very small numbers. So an astronomer would have to use very big numbers. Usually for distance, they use the light year because distances in space are very vast. But if they're expressing stuff in kilometers, there is an easier way to express it. On the other side, we have biologists that might deal with very small organisms that are going to be to the decimal place of meters and that. So this is why we have scientific notation, because it makes it easier to write these large distances or very small small measurements. So for scientific notation, you have a coefficient. So a coefficient is just a number. Okay? And then you multiply that by 10 raised to a power. Okay? So for example, the distance from Earth to the Sun is about 150 billion meters. Now, instead of saying 150 billion meters, we would say 1.5 times 10 to the 11th. So if we look at this, say 1.5, so they say that's where our decimal place is. If we times it by 10, we move the decimal place 1 to the right. Now we are multiplying it by 10 11 times total. So 1.5 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So our coefficient in this is 1.5. So the coefficient needs to be equal to or greater than 1 and less than 10. So the power of 10, or exponent, is 11 because you have to do 1.5 times 10 to the 11th to get the correct number. All right? So on the other side, when we're working with small numbers, we use a negative exponent. So with a positive exponent, whatever your exponent is, that is how many times you move your decimal place to the right. Okay, so this one we move our decimal place 11 spots to the right. When it is a smaller number, we use a negative exponent because that indicates that we are moving our decimal point to the left. So 0.1 meters is going to be 1 times 10 to the negative 1 meters, because our decimal point would be right here, and when we multiply it by negative 1, we move it 1 to the left and get 0.1. So 0.01 meters is going to be 1 times 10 to the negative 2. Because we take 1, we move the decimal point 1, 2 places to the left to get this number. All right? So, they talk about the leading zero, the zero to the left of the decimal point. You can or cannot use that. That is up to you. It's just a little bit easier to read when you have 0 point something than when you have point something, but I will accept either answer. So make sure you do your questions and turn them into me.